Welcome to SAP 2000 V18 training. By Engineer. Untitled Saxon BE Structures. 5th, Chartered Engineer. Introduction to SAP 2000 Part 2. Analysis. CSI solvers have been tried and tested by the industry for over 35 years. The SAP Fire Analysis Engine can support multiple 64-bit solvers for analysis, optimization, and perform both eigenanalysis and Ritz analysis. Static. SAP 2000 can perform both linear static and multi-step static analysis. The linear static analysis of a structure involves the solution of a system of linear equations represented by Ku equals R. Certain types of load patterns are multi-stepped, meaning that they actually represent many separate spatial loading patterns applied in sequence. These include the vehicle, live, and wave types of load patterns. Dynamic. SAP 2000 dynamic analysis capabilities include the calculation of vibration modes using Ritz or eigenvectors, response spectrum analysis, and time history analysis for both linear and nonlinear behavior. Eigenvector modal analysis finds the natural vibration modes of the structure, which can be used for understanding the behavior of the structure, and also as the basis for modal superposition in response spectrum and modal time history load cases. Ritz vector modal analysis finds the optimum modes for capturing structural behavior in response spectrum and modal time history load cases, and is more efficient for this purpose than eigenvector analysis. Model. Response spectrum. Response spectrum analysis determines the statistically likely response of a structure to seismic loading. This linear type of analysis uses response spectrum ground acceleration records based on the seismic load and site conditions, rather than time history ground motion records. This method is extremely efficient and takes into account the dynamical behavior of the structure. Time history. Time history analysis captures the step-by-step response of structures to seismic, ground motion, and other types of loading such as blast, machinery, wind, waves, etc. Analysis can use modal superposition or direct integration methods, and both can be linear or nonlinear. The nonlinear modal method, also called FEMA for fast nonlinear analysis, is extremely efficient and accurate for a wide class of problems. The direct integration method is even more general, and can handle large deformations and other highly nonlinear behavior. Nonlinear time history analysis can be chained together with other nonlinear cases, including staged construction, addressing a wide range of applications. Buckling. Linear bifurcation. Buckling modes of a structure can be found under any set of loads. Buckling can be calculated from a nonlinear or staged construction state. Full nonlinear buckling analysis is also available considering p-delta or large deflections effects. Snap-through buckling behavior can be captured using static analysis with displacement control. Dynamic analysis can be used for modeling more complex buckling, such as follower load problems. P-delta. P-delta analysis captures the softening effect of compression and the stiffening effect of tension. A single P-delta analysis under gravity and sustained loads can be used to modify the stiffness for linear load cases, which can later be superposed. Alternatively, each combination of loads can be analyzed for full nonlinear P-delta effects. P-delta effects are included for all elements and are seamlessly integrated into analysis and design. Pushover. Pushover analysis features in SAP 2000 include the implementation of FEMA 356 and the hinge and fiber hinge option based on stress-strain. The nonlinear layered shell element enables users to consider plastic behavior of concrete shear walls, slabs, steel plates, and other area finite elements in the pushover analysis. Force-Deformation relations are defined for steel and concrete hinges. Time-dependent. Staged construction is a type of nonlinear analysis in SAP 2000 that allows you to define a sequence of stages wherein you can add or remove portions of the structure, selectively apply load to portions of the structure, and to consider time-dependent material behavior such as aging, creep, and shrinkage. Staged construction. Creep and shrinkage. Long-term deflections due to creep and shrinkage can be computed along with staged sequential construction analysis. Time-dependent material properties are based upon the 1990 edition SEB FIP code, and user-defined curves are used to compute creep strains. Power spectral density. Power spectral density analysis is available to determine the probabilistic response of a structure due to cyclic, harmonic, sinusoidal loading over a range of frequencies. This is useful for fatigue studies, random response due to earthquakes, and other applications. Multiple loads may be applied at different phase angles, and may be correlated or uncorrelated. Steady state. Steady state analysis is available to determine the response of the structure due to cyclic, harmonic, sinusoidal loading over a range of frequencies. Frequency-dependent stiffness and damping, complex impedance properties may be included for modeling foundations and far-field effects, including radiation damping. Steady-state analysis can be used to measure the effects of multiple machines operating at different frequencies, can be considered by combining the results of several analyses in the same model. Target force. During nonlinear static analysis, cable and frame elements can be automatically strained to achieve specified target axial force values. This is most commonly used to tighten cables to pre-specified tensions, but it can also be used to jack structures to a specified force using frame elements, as well as other applications. Load combinations. SAP 2000 allows for an unlimited number of load cases and combinations. Load combination types include linear additive, envelope, min/max, absolute add, SRSS, and range combinations. Combination components can include other combinations. Model alive. For small to medium-sized structures, analysis can be performed on the fly as you build and modify the model. For each change you make to the geometry, properties, or loading, the structure instantly responds with a new deformed shape, moment diagram, or any other plot of results. It's like working with a live model, and it is a very powerful tool for conceptual design and for testing what-if scenarios. Design. Fully integrated steel frame design includes member size optimization and implementation of design codes. SAP 2000 allows users to interactively view design results at any frame member, change the parameters or section properties, and display the updated member results. All major codes are supported. Concrete frame. Fully integrated concrete frame design in SAP 2000 includes required area of steel calculations, auto selection lists for new member sizing, implementation of design codes, interactive design and review, and comprehensive override capabilities. Aluminum frame. AAASD2000 and AALFRD2000 codes are supported. Cold form frame. ICASD96 and ILFORD 96 are supported. Output and display. Deformed geometry. Users can display deformed geometry based on any load or combination of loads, as well as animations of modes. Force diagrams. Shear and moment diagrams display internal shear forces, moments, and displacements at all locations along the length of a frame element for any load case or load combination. SAP 2000 gives the option to scroll along the length to display values or scroll directly to the maximum value location. General displacement. Arbitrary displacement measures can be defined using generalized displacements. These are linear combinations of joint translations and rotations, and can be used to calculate averages, drifts, and other quantities of interest. Generalized displacement output can be obtained for all types of analysis cases and combinations. Section cuts. The resultant, free body, forces and moments across any cut in the structure can be defined using section cuts. A section cut can have any shape, and can be used to compute story shears, connecting forces, design forces and shear walls, and for many other purposes. Section cut results can be obtained for all types of load cases and combinations. Virtual work diagrams. In SAP 2000, virtual work diagrams can be used as an aid to determine which elements should be stiffened to achieve the most efficient control over the lateral displacements of a structure. Influence lines. SAP 2000 uses influence lines to compute the response to vehicle live loads. Influence lines are also of interest in their own right for understanding the sensitivity of various response quantities to moving loads. Influence lines may be displayed in the user interface for the displacement, force, or stress response of any element in the structure. Tabular output. SAP 2000 has the ability to display tables for all input data, analysis results, and design results. Tables support sort, cut, copy, and paste for use in other programs. Print or save tabular data to access Excel, Word, HTML, or text. Video animations. SAP 2000 has the ability to generate video.avi files to visually display a set of analysis results that vary over a particular time period, such as in a time history analysis. Reporting. Quick report. Pre-formatted printed reports are now available at the push of a button. These reports include all pertinent model data and the results of analysis and design. Data is presented in tabulated format, along with graphics, table of contents, and a cover sheet displaying project information and your company name and logo. Advanced Report Writer. The Advanced Report Writer is a robust utility that can be used for creating sophisticated reports of the SAP 2000 model. These reports are fully customizable. Companies can define and save complex template files to standardize the analysis and design report generation. Tools. Load Optimizer. The Load Optimizer is a tool in SAP 2000 to compute the optimal load application to achieve desired structural response. Loads may be applied linearly, non-linearly, or in staged construction. Goals and limits may include displacements, forces, moments, and more. Section Designer. Section Designer is a utility that is built into SAP 2000. It allows users the ability to create specialized sections of any arbitrary shape and material, including rebar layout. All sections' properties, biaxial interaction diagrams, and moment curvature diagrams are automatically calculated. Import and export. Supported formats. SAP 2000 supports many industry standards for importing and exporting data. Autodesk Revit Structure, Tekla Structures, AutoCAD, DXF/DWG, SYS/2, IFC, IGAS, and SDNF are all supported. SAP 2000 also supports exporting of a model to a Microsoft Access database.